So just be careful because this is the easiest one to mess up. There's only, if it's not a right triangle, there's only two options. You've got a 50-50 chance. But most of the time, if you just guess, you're probably going to guess wrong. So let's remember how I taught y'all to set these up. I taught you to absolutely write it backwards. Because if you write Pythagorean theorem backwards, when you get a greater than sign, it's going to be obtuse. And when you get a less than sign, it's going to be acute. But you have to remember that it's really important to write it backwards, okay? So what we have to do on number 1 is we have to find out which one C is. Which one of those numbers is the largest? Is it 8 or is it 6 root 3? It's 6 root 3, absolutely. So that's what we're going to do first. We're going to do 6 root 3 squared, and we're going to see how is that related to 8 squared plus root 5 squared. And so this is why it's important to know how to square radicals. Let's see, that's 36 times 3, 108. And the other side, 8 squared plus 5, because the square root of 5 squared will cancel. And then the sign is going to eat the bigger number, right? Chomp, chomp, chomp. Eat the bigger number. And therefore, very good, Hussein. Our answer is obtuse. Are y'all done with number 2, or do you need more time? Done, done, done. Okay, on the count of 3, type your answer. 1, 2, 3. Whoosh. So one's obtuse, so the other one's just going to be acute, right? Okay. Which one was C? It was obviously 28 root 2, correct? That's the obvious largest one. Always put C squared first, and then put A squared plus B squared. So let's see, these numbers are getting large, huh? Did you get 1,568? And then 841. Guys, how'd you all 3 get it wrong? Oh, okay, now you have it right. Oh, you left off the 1 in front of 1,568. Oh, spelling error. Y'all are funny. Oh my goodness. You know what? I was really about to just say acute and then move on, but I'm really glad I worked it. Yikes. Hey guys, when you square 28 root 2, make sure you square the 28 and the root 2. 28 squared is 784. And then you multiply it times 2 because root 2 squared is 2. So it's 784 times 2. And that number is definitely larger than 20 squared plus 21 squared. Okay, let's move on to the homework answers. What'd y'all think of this homework? Pretty straightforward, or is it tricky? While y'all are checking answers, I will fill space with my voice and just remind you what we learned on Friday. We learned about right isosceles triangles. We learned about 45, 45, 90 triangles. And we learned that every single time they follow this rule. So there's no need to do Pythagorean theorem ever again with a 45, 45, 90 triangle because they follow this neat rule. X, X, X root 2. We learned that when you're finding a hypotenuse, you multiply by root 2. And if you're finding a leg, you divide by root 2. So you're either multiplying or dividing by root 2. That, Hussein, that's great. 3.5 root 2 will work. 7 halves or 3.5, those are equivalent, so that's fine. Just don't ever put a decimal inside a radical. It can be outside, just don't put it inside. Okay, do y'all have any for me to work? If not, we're going to move on. Any of them that you were stuck on you want me to do? Carson says no. Watkins, you got anything? Aw, man. Okay. Well, I won't work any of them then. Y'all are too smart for our homeworks. 12 through 18. There's a square and a kite and a trapezoid and another square. Looks like we're getting into the quadrilateral unit. Is that hard to see? There you go. I would love to. Thank you for asking. $14. Okay. This entire unit is called the right triangle unit. You cannot do anything unless you have a right triangle. So the problem is we've got a trapezoid. We don't have a right triangle. And let me just warn you, some people are tempted to try to make a triangle by doing something like that. That is never going to help us. First of all, it doesn't even make a right triangle. But second of all, we cannot even find that length, so it doesn't really help us. You always, what I recommend is you always draw an altitude. Always draw an altitude of some sort. Like this is an altitude. This is an altitude. So we know that this is 6. What are we trying to find? Oh, the perimeter. We need the perimeter of the whole figure. Okay. And we know that these are 45. So it's kind of tempting to be like, oh, 6, 8, 10, but that has nothing to do with this problem actually. So we've got a 45, 45, 90 triangle. And we know that we can go backwards and we can divide by root 2. So we're going to do 8 divided by root 2. But then we would need to rationalize the denominator. So we're going to get square root 2 times square root 2 is 2. 8 times root 2 is 8 root 2. That's going to cancel, and we're going to get 4. So we know this is 4 root 2. We know this is 4 root 2. This is an isosceles trapezoid, so that one's going to have to be 8. Now, please hear me now. This is so important. You add integers with integers and radicals with radicals. Please never combine an integer with a radical. This is very, very important. Okay? So I want you to add 6 plus 6 plus 8 plus 8. So we're adding this plus this plus this plus this. Then you get 28. Then you can add your radicals. 4 root 2 plus 4 root 2 is naturally 8 root 2. So that's where this comes in. You do not combine them. You write your answer as the integer plus the radical. They're separate terms. It's like an x and a y. Okay, now I'm going to do number 13. Number 13. $45 and 3 root 2. So remember, our rule is x root 2. And we're used to the root 2 being across from the 90. But when it's not across from the 90, it's no big deal. We don't sweat it. We just follow our pattern again. So it goes x root 2. But instead, it's going to be 3 root 2, 3 root 2, 3 root 2, root 2. You take whatever x is, you take what's across from 45, and you multiply it by root 2. Well, 3 root 2 root 2 is 6. You can think of it if you really want to, you can think of it as 3 root 4. The square root of 4 is 2. And then we come up with 6. Okay, it's asking for the perimeter of the figure, so I'm not going to stop there. I'm going to keep going. So we know that this side, we're good with this. This side is 6. We know that this is 3 root 2. Now, look at this big triangle. If this big triangle is a right triangle and it's got an angle of 45, what does that other angle have to be? It has no choice. If you've used 90 and you've used 45, the only thing you have left is another 45-degree angle. So this is actually a 45, 45, 90 triangle. So let's do our pattern. X, X, X root 2. 6, 6, 6 root 2. And that 6 came from the 3 root 2 plus the 3 root 2. Okay, ready? Final answer. You add integers plus integers and radicals plus radicals. So how many integers do we have? 6 plus 6? 12. And then the only radical we have is that hypotenuse, and that hypotenuse is 6 root 2. Okay, let's move on to today's lesson. That's weird. Somehow I jumped to the end of the lesson. That was cool. Alright, so this is called Special Right Triangles 2. The good news is we're going to learn another shortcut. So we already learned a shortcut that helped us bypass Pythagorean theorem. Not using it when it's 45, 45, 90. Don't ever use it again. Now we're going to learn there's one more group of special right triangles out there that also has a cool trick where we can be given one side, and once you know one side, you're going to know all 3 sides of a right triangle. What do we know about this figure? What is A? A number. Thank you. It's a right triangle. Yep. What do these two add up to? What is this plus this? 3a, and they have to add up to 90. Very good. So 2a plus a, we know that's 3a, but we also know that those two angles, they have to equal 90 because we've got 180. We've already used 90, so we've got 90 left. So what's a? Carson already got it? A is 30. So that makes this angle 30, and that makes the other angle 60. So today's lesson is called, the triangles we're going to study today are called 30, 60, 90 triangles. 30, 60, 90. All right. So we're going to use Pythagorean theorem to find the length of the missing side, and we're going to simplify our answer. Okay. I have the work on a different slide. Let's do the work. This is the only time we'll ever do the long way. Then we'll know the shortcut, and then we'll do the shortcut from now on. Okay? So do this with me, please. 36 equals 9 plus x squared. 27 equals x squared. X is the square root of 27. So x is 3 root 3. All right, you want to do the next one? 64 equals 16 plus x squared. What did we do first? Subtract 16. 48 equals x squared. X is the square root of 48. 48 is 16 times 3. 16 is a perfect square, so I'm going to go straight to 4 root 3 if y'all don't mind. All right. So that is finding the missing side the long way. What do our two answers have in common? obviously. Yeah. So on Friday, the radical that we saw over and over was square root 2. Today, maybe that radical that we're going to see over and over is square root 3. It's going to be a little bit more complicated than that, though. So let's put our answers back into the triangles. There's our answers. We did all that work and we got those answers. We need to come up with a pattern that we can use every single time. It's not quite as easy as x root 2, right? Okay, I want you to take a look at what's across from 30, because every time that number is going to be the key to our whole problem. So let's look at the triangle where 3 is across from 30. How do you get from 3, how do you get from your shortest side to your medium side? 3 root 3. How do you get from your shortest side to your longest side? 3 times 2. Let's see if that happens in the other triangle. Look at your shortest side, it's 4. How do you get to your medium side? Take your shortest side, root 3. How do you get to your hypotenuse? Take your shortest side, times 2. Okay, so in all of these problems, the key to solving these are find what's across from the 30. Find what's across from the 30. Find what's across from the 30. We're not going to do that one. Okay. So I'm going to give you a minute to write this down. This picture is in your formula chart, so you don't need to memorize the picture. You just need to memorize how to use it. X root 3, 2x. X root 3, 2x. Okay, so let's try some problems using our fancy new trick. Now, when the problems are basic like this, I just recommend that you use your trick and you just go for it and you just solve it. When they get a little tougher, I'll show you a table trick that you can use. Very good, Taha. All right, so you always look for what's across from the 30, and that's the key to the problem. Thankfully, we're given what's across from the 30 this time. So it's x root 3, 2x. X root 3, 2x. We didn't do any Pythagorean theorem. We hardly did any math. This is an awesome shortcut. Always get what's across from the 30 first. So I want you to find J first. Y'all are too good. Ugh. Very good. So you understand that the short leg and the hypotenuse are always, the short leg is always half of the hypotenuse, every time. The short leg is half of the hypotenuse. So you take 24 and you divide it by 2, and then you know what the drill is, x root 3, 2x. X root 3, 2x. Okay, let's try to get a harder one. This is not a harder one. I'm just showing you one of each, okay? Very good. Always get what's across from the 30 first. So what's across from the 30 is whatever is being multiplied by root 3. So you take what's across from 60, you divide by root 3. 2, and then you double it, because the hypotenuse is always double the shortest side. Okay. You always want what's across from 30 first. And you got it. Except this time it's a little funky. It's a radical. You're going to be okay. Yeah. So we've got x root 3, 2x. Oops. Sorry. X root 3, 2x. X root 3, 2x. This one's done. This one needs some work. Square root 3 times square root 3 is 3. So be careful. People start to get confused when across from 60 it's an integer and across from 30 it's a radical. But don't get confused. It's okay. There's a radical 3 in that 3 somewhere. It's just kind of buried. If you can tell, what people are tempted to do on this problem is take that root 3 and say, oh, there's a 1 in front of it, so the missing side is 1, and the missing hypotenuse is double 1. That's what they're tempted to do. But just be aware that the square root 3 is not across from the 60, it's across from the 30. And now we're getting a little bit uglier. I'm going to show you something, and if you think I'm babying you, then you never have to do it again. But if this helps you, just a minute. It always stops on a very unflattering picture. Okay. Here we go. So, I'm going to show you something. Take it for whatever you want it. X root 3, 2x. This is 30, 60, 90. Sometimes it helps to say, okay, what do I have and what is it across from? What do I have and what is it across from? I've got a 12 and it's across from 60. So in my little table, if you wanted to make a table, you would put 12 and it's across from 60. 12 is in the x root 3 column. It doesn't have a root 3. So the opposite of multiply by root 3, remember we always want to get 30 first. We always want to go here first. The opposite of multiply by root 3 is divide by root 3. So unfortunately you're going to have to take what's across from 60 and you're going to have to divide by root 3. So A is 12 divided by root 3. Except you can't leave your answer like that. So you do a little bit of work to it. And you get square root 3 times square root 3, 12 times square root 3. And you're going to cancel those out in 4. So now x is 4 root 3. So we've got 2 of our 3 sides. We've got 4 root 3, we've got 12, and then we don't know what the last one is. This column says 2 times x. Take x and double it. Take 4 root 3 and double it. Take 4 root 3 and double it. There you go. So A is 4 root 3 and B is 8 root 3. And that's can't really get much harder than that. So, once again, if you would like to make the chart for a while you're getting used to it, then make the chart. X root 3, 2x. What do I have and what is it across from? What do I have and what is it across from? What do I have and what is it across from? I've got 2 root 6 and it's the hypotenuse. I've got 2 root 6 and it's the hypotenuse. Always find x first. Always find x first. So if 2 root 6 is double what I need to undo it. I need to divide by 2. 2 root 6 divided by 2 is just root 6. And then this just follow what it says. Take x and multiply it by root 3. Take x and multiply by root 3. Okay, that's right. Okay. Root 18, which you would factor tree. You would factor tree and get 3 root 2. So this is across from 30, this is across from 60, and this is across from 90. 30, 60, 90. So C is 3 root 2, and D is root 6. Now we've got 2 of our special triangles in one figure. Let's do the 30, 60, 90 one first because that one's fresh on our minds. We've got an integer across from 30, so I'm not going to do my table because this is one of the easy ones. So across from 90, It's 30, and we don't really need this, but there we go, 15 root 3. All right. Now we have to find our 45, 45, 90 triangle. This one's 45, 45, 90 because it's isosceles. We know when we're going forward, we multiply by root 2. When we're going backwards, we divide by root 2. So this is 15 divided by root 2. And when all is said and done, when you rationalize the denominator, you get 15 root 2 over 2. If you wanted to put 7.5 root 2, that would be okay. But it's root 2, Hussein, because you have to divide by root 2. Yeah, good. I'm going to wait a minute and not talk and let you look at this one because I know I'm talking too much. So we've got to start with what we're given. We are given 12, and 12 is across from 90. So you always ask yourself, what do I have and what is it across from? 12 is the hypotenuse. So let's cut 12 in half. Let's cut 12 in half, and now we have the short leg because we know the short leg is always half the hypotenuse. Okay? Now I can find what's across from 60 because we know our rule, it's 6 root 3. Now we come over to this triangle, it's a little bit tougher. What do I have and what is it across from? I've got the hypotenuse again, so I need to cut it in half. I've got the hypotenuse, I want the short leg. So I just take the hypotenuse and cut it in half. And there we go. X is 3 root 3 and Y is 6. So when you said 9, that's what this side is. Across from 60, this is X root 3. So this is 9, but we weren't looking for the one across from 60, okay? So you did find a side of the triangle, but you didn't find X. That's a different side. Yeah. How many more do we have? Let's check. This is the last one. The square has sides 20 inches long. How long is the diagonal? Yeah! So now you can find the diagonal of any square very quickly because you know that the angles of a square are 90. And that creates an isosceles triangle. So it's got to be 45, 45, 90. And then you use your rule, your trick. X, X, X root 2. 20, 20, 20 root 2. Alrighty. We are done.